So this is number 6 from the 2016 exam. It says the function f has a Taylor series about x equals 1. And that's kind of interesting because usually they center things around 0. This one's centered around 1, which doesn't make it any harder. You just have to remember to put an x minus 1 in all of your terms. Converges to f of x for all x in the interval of convergence. It is known that f of 1 equals 1, f prime of 1 equals negative a half, and then after that, they give you a formula to find the derivatives. So finding the second derivative at 1 and the third derivative at 1, we'll just plug in 2 and 3 and so on and so forth. All right, so letter A, write the first 4 non-zero terms and the general term for the Taylor series around 1. I always write out the pattern. I have to, I don't know, I need to write it out in order to stay organized. So it's the 0th derivative, which is just the original function over 0 factorial x minus 1 to the 0. And then you have the first derivative at 1 over 1 factorial x minus 1 to the first. And then the second derivative at 1 over 2 factorial x minus 1 to the second. I think they said do the first 4, so we got to do one more. Third derivative at 1 over 3 factorial x minus 1 to the third. That's not necessary to write that out. I just always do because I need to. It just helps me stay organized. All right, so f of 1 they gave us, that's 1. So we're going to have 1 over 0 factorial x minus 1 to the 0. Technically, that would all just be 1. Again, I just write it out. All right, f prime of 1 is negative a half. Okay, so actually this is going to be negative. The terms are going to alternate here. So minus, and then this numerator part is a half. It was negative a half over 1 factorial, and then x minus 1 to the first. All right, and then now when we go to get this second derivative at 1, we have to use this formula. So we're going to plug in 2 for n. So negative 1 squared, that would be a positive 1. So this is going to be a positive term. 2 minus 1 would be 1, and 1 factorial would just be 1, over 2 squared. Again, we're plugging in 2, so 2 squared would be 4. So this part right here is 1/4, and then that's over 2 factorial x minus 1 squared. All right, and then we're going to plug in 3 to this. Now, if you do negative 1 to the third, it's going to be negative. So again, the terms are alternating, positive, negative, positive, negative. And we're going to plug in to get this numerator part. It's still going to be over 3 factorial and then x minus 1 to the third. We're just plugging in to get this portion of it. So plugging in 3, again, that's going to make it negative. 3 minus 1 would be 2. 2 factorial is just 2 times 1. So that would just be 2. And then 2 to the third. Again, we're plugging in 3 for the third derivative here. 2 to the third is 8. So those are the first 4 non-negative terms. Now we have to do the general term. So it's kind of nice if you don't simplify too much. I'm going to write this off to the side because then we are going to kind of cancel some things out here. We're going to start with n being 0. So this is going to be the 0th term, the first term, the second term, the third term. So it's going to be over n factorial and then x minus 1 to the nth. This is to the 0, to the 1, to the second, to the third. So this numerator part, the part that we get here, comes from this formula. So we have that, and it's kind of nice they gave that to us. Negative 1 to the n minus 1 factorial over 2 to the n. That's the numerator part. We're putting that over n factorial. So I'm just going to put an n factorial in the denominator with this. So it's this formula over n factorial and then x minus 1 to the n. The reason I wrote it off to the side is because I was going to run out of space. We do want to simplify this down a little bit because these are going to cancel. If you have n minus 1 factorial, that's going to be 1 times 2 times 3 all the way up to n minus 1. You have n factorial. That's going to be the same thing all the way up to n minus 1, but then times n. It's going to go once further. So everything's going to cancel out except for that n that's in the denominator. So it's going to be negative 1 to the nth over 2 to the n times n, and then x minus 1 to the nth. And you don't have to put that n starts at 0. I just like to do that because sometimes you start with the zeros term and sometimes you start with the first term. Like sometimes it starts with 0 and sometimes it starts with 1. So I always like to put that in there. This is the zeroth term, first term, second term. So again, I know that looked like a lot, but again, it was just this formula that they gave us over n factorial x minus 1 to the nth. And then we had some stuff cancel out, so it sort of simplified that. That was letter A. Now this was worth a lot of points, which I think was actually kind of nice because they gave this formula, which made it not as hard as it could have been. It was a point for these first two terms, a point for this term, a point for this term, and then a point for the general term. So that was worth 4 points. And again, it was helpful that they gave this formula. So it was really nice. All right, letter B. The Taylor series for f about x equals 1 has a radius of convergence of 2. Find the interval of convergence. What you have to do is check the endpoints. So this is centered at 1, and they just told us that the radius is 2. So we're going to go 2 in each direction. So that'll take us to -1 and +3. So we are going to let x equal -1, see what we get, see if it converges or not. And then let x equal 3, see what we get, and see if it converges or not. And this is the general form that we're using. So the only kind of bad thing about problems like this is if you were unable to get this, then you'd be out for the rest of the problem because you need it in order to do the rest of it. But again, they gave us this, so that was like a big chunk of it. All right, so if we let x equal -1, this is going to be sum from 0 to infinity. And we'll have -1 to the nth over 2 to the nth times n. And then again, we're plugging in -1 for x. So that'll be -2 to the nth. So what's going to happen there is this would be -1 to the nth times 2 to the nth if you wanted to separate that. And so the negatives are going to cancel. So it would just be 2 to the nth over all of that stuff in the denominator because those negatives are going to cancel out. And then these cancel out too. Sorry, I had trouble writing my sigma there. So it'll just be 1 over n. And so that's a p series where p is 1, and so that diverges. So we're not including that n. All right, now we're going to do the exact same thing, except let n equal 3. So it's going to be -1 to the nth over 2 to the n times n, and we're plugging in 3. So 3 minus 1 would be 2, and then to the nth. So these are going to cancel, and we're left with -1 to the nth over n. So that's an alternating series. So our alternating series test, we're going to do limit as n goes to infinity of 1 over n. You leave out the alternating part, just the 1 over n. That has to go to 0, which it does. And if you plug in n plus 1, that has to be smaller than just what you have there, 1 over n. In other words, the terms have to be decreasing, and they are. And so this converges by the alternating series test. So we do not want to include the -1, but we do want to include the 3. So our interval of convergence is parenthesis on the -1 and a bracket on the 3. So it was a point for checking these two endpoints. So if you even, identified those two endpoints, you got a point. I think that was nice. And then it was a point for the answer with the analysis. So 2 points for that. All right, part C says, the Taylor series for f about x equals 1 can be used to represent f of 1.2. So we're going to use it to, do an estimation. Use the first 3 non-zero terms to approximate f of 1.2. I'm going to need to back out here because I wish I could fold the paper over, but I need to use what's already written there. So we're going to use the first 3 non-zero terms. So those are these right here. And literally all you have to do is plug in 1.2, which is really nice. This is only worth 1 point, but all you have to do is plug in 1.2 to these terms. This first term is just 1. 0 factorial is 1, anything to the 0 power is 1. So that's just 1. Minus, this would be a half, and then we'll have 1.2 minus 1. And then plus, you don't even have to simplify that. I was thinking maybe I'll simplify that down. You don't even need to. All you have to do is plug in 1.2. And that's it. You get a point for that. So just plug in 1.2 to the first 3 terms, and you're good. All right, and then part D, show that that approximation that we just found, this here, is within 0.001. So that's 1/1000th of the exact value. All right, so this is your alternating series error. So your absolute value, it's the error of the actual value, excuse me, I'm talking so much all day, I can't talk anymore. The actual value, the difference between that and the approximation. So this was, usually they put P for polynomial. I think on the answer key, they put T for a Taylor polynomial. If you put a P there for polynomial, whatever, you can put whatever letter you want. Now it was the 1 to the 2nd power. So it was the 2nd degree at 1.2. So the difference between the actual value, this is like the actual answer. And then this is our approximation. So the error is the difference between those. You absolute value it so you don't get a negative error, but the difference between those has to be smaller than the next term, the absolute value of the next term. So since that one was to the 2nd power, it has to be smaller than the term to the 3rd power. And so that's this one right here. It's just the next one. Now it is negative, but we're going to absolute value it. This is 2/8, that's 1/4 over 3 factorial. That's 3 times 2 times 1, so that's 6. And we're plugging in 1.2 for x. And then that's getting cubed. All right, so we just have to show that this is going to be smaller than 1/1000th. It said 0.001. So the negative is going to go away when we absolute value it. This would be 1/24 times, let's see, this would be just 0.2, which would be a 5th to the 3rd. And so that would be 5 cubed is 125. I don't even think you would need to go that far. That's going to be smaller than 0.001, which is 1/1000th. And you know it's going to be because it said show that. Like, you know it's true, you're just trying to show it. So you don't really need to go too far with this. You just need to say it's less than 1/1000. So it was a point for it said the form of the error. So actually, let me go back and see exactly how they worded it. It says a point for the error form. Which I would assume they would say take this. So if you did the form of that and then a point for doing this analysis.